Hi all, this is Dr. K.G. Shanti, Professor, EC Department, R.M.K. College of Engineering and Technology, an institution that is affiliated to Anna University. Now in this presentation we are going to see about basic elementary, or the other name for it is standard signals. Let's look into the actual definition of signal. Any phenomenon that occurs in the nature can be represented as a function of one or more variables. What are those variables? Independent variable and dependent variable. Right? Why do we call voltage as a dependent variable and why time is called as a independent variable? Let's look into the waveform. The value of x of t is given at any instant of time. Say for example, at this instant the amplitude is some value. At this instant of time the amplitude is 0. Right? At this instant of time it has a negative amplitude, which means that x of t is dependent on time. The value of x of t depends on time. Hence x of t is called as a dependent variable and t is called as an independent variable. Right, now this is the continuous time representation of the signal. Right, now you have a discrete time representation of the signal, which means that x of n is defined only at discrete values of n, which means that n is 1, 2, 3, 4, so on, where n varies from minus infinity to infinity. Basic, elementary or standard signals. The following are the elementary signals which will be used for building complex signals. Step signal, ramp signal, impulse signal, parabolic signal. They are going to be called as test signals because we will be using them for testing systems. Okay. Sinusoidal signal, sync signal, rectangular signal, signum signal, triangular signal, exponential signal. Now all these signals will be used as inputs for processing the operation or for checking whether the systems are working perfectly. And for all these elementary signals, we are going to study both CT and DT domain of them. Now let us study about step signal. Why this signal is called as a step signal is it's because of the shape of the signal. The shape of the signal will be like this. Right? It is represented in CT form as U of t and in DT form as U of n. Now let us look into the signal. Now look into the signal. Here time is t is equal to 0, right? And for to the left of 0, t is lesser than 0. To the right of 0, t is this side, for t is greater than 0. Now how will you define the signal? X of t is equal to a for t greater than or equal to 0 and it is equal to 0 for t lesser than 0, right? Yes or not? Right, now that is what is written here. X of t is equal to a for t greater than or equal to 0. So this part of your graph, right, and it is equal to 0 for t lesser than 0. Right, now the same signal represented in dt form, how do you represent it? X of t is represented as x of n and the time index t is represented as n here, right? Now how will I define here? X of n is equal to a, yes or not, for n greater than or equal to 0 and it is equal to 0 for n lesser than 0, right? Now the same signal, if the amplitude a takes a value of 1, then I am going to call that signal as a unit step signal. Why? Because the value of a is nothing but 1 in this case, correct? So when the amplitude is 1, you call that signal as unit step signal. How will you define this signal now? U of t is equal to 1 for t greater than or equal to 0 and it is equal to 0 for t lesser than 0. The same way, how will you define in discrete time? See here, when you look at this waveform, you define this way. U of n is equal to 1 for n greater than or equal to 0, which is nothing but the right hand side of your signal, and it is equal to 0 for n lesser than 0. So if the amplitude is 1, then either CT signal or DT signal, you are going to call it as unit step signal. Applications of step signal you can come across in our day-to-day lives. Now when you start your car, right, how will you start? You either key in your car, that is you insert a key and then trigger it, or you switch on a button, right? In any case, a step voltage is introduced into the starting motor. In the same way, when you apply the brake to an automobile, once again a step function is used. The next signal what we are going to see is a ramp signal. Once again, why we call this a ramp? It's because of the shape of the signal. The shape of the signal is going to be like a ramp. Okay, right. Now how will you define the signal? Look into the signal here. So for 0, R of t is 0. When t is equal to 1, what is the value of R of t? R of t is 1. For time t is equal to 2, R of t is equal to 2. For time t is equal to 3, R of t is equal to 3. So when you look at the waveform itself, how will I define now R of t? R of t is equal to t for t greater than equal to 0. Am I right? Why? Because when t is equal to 0, R of t is 0. When t is equal to 1, R of t is 1. When t is equal to 2, R of t is equal to 2. So that is how I define the signal, right? Now the same signal when I write it in dt form, see here. So same way, for when n is equal to 1, R of n is 1. When n is equal to 2, R of n is equal to 2. Right? So once again, how will I define the signal? R of n is equal to n for n greater than 0. So for this part, and it is equal to 0 for n lesser than 0. That is to the left hand side of 0. Right? And applications of it, it is used in current and voltage circuits. The next signal what we are going to see is a parabolic signal. Correct? Now as the name indicates, the shape of the signal is going to be in the form of a parabola. Right. It is represented as Pt in Ct domain and P of n in Dt domain. Right. Now look at the shape of the signal. When you look at the shape of the signal, it's in the form of a parabola, and the equation is, we all know the equation of a parabola, x of t is equal to at square by 2. Here what is a representing? A is nothing but the amplitude. The factor a can take a value, any value from say 1, 2, 3, 4, anything, right? A represents the amplitude. And you get the shape of the parabola because of this function t square by 2. Right? Now this is in the case of a CT signal. In the case of DT signal, how will I define? Right? In the case of a DT signal, how will we define? X of n is going to be equal to, same way, a n square by 2 for n greater than or equal to 0, and x of n is equal to 0 for n lesser than 0. Right? In this case, depending on the value of a. Right? Now, if I take a as 1, what will be my equation? Equation is going to be n square by 2. Now see here, look at this diagram here. How is that I have defined? I have taken the a value of a to be 1. In that case, p of t is equal to t square by 2 for t greater than or equal to 0. Right? Now you all know how to substitute. Right? When t is equal to 1, it is 1 by 2. Right? When t is equal to 2, t is equal to 2 means what? 2 square, 4 by 2. So at t is equal to 2, what is p of t value? P of t value is 2. Okay. At t is equal to 3, 3 square is 9, 9 by 2 is 4.5. At 3, what is the value? 4.5. Correct? So this is how you write the equation for a parabolic signal. And if the amplitude is 1, you represent it as p of t. And here, once again, you represent dt signal. And the main application of a parabolic signal is it is used as a acceleration function. You have accelerators in your cars and bikes. So the signal what we give there is a acceleration function. Okay. Right, and the relationship between all these three signals is very clearly given here. I'll tell you how you get it. Right. Now I have a unit ramp signal. Right. How do you get a ramp signal? You all know what is a unit step signal. What is unit step signal? U of t, right? What is u of t? U of t is equal to 1 for t greater than or equal to 0, right? Integrate u of t. U of t is 1. So when I integrate 1 into dt, integral of dt is t. What is t? Which is nothing but a ramp signal. So when I integrate a unit step signal, I get a ramp signal. In the same way, take a ramp signal. Integrate a ramp signal. When I integrate a ramp signal, right, what is r of t? T into dt. So when I integrate it, I get t square by 2. What is t square by 2? It's nothing but parabolic signal. Now the reverse. So differentiate a ramp signal, you get a unit step signal. And when you differentiate a parabolic signal, what do you get? You get a ramp signal. The next signal what we are going to see is a impulse signal. Right, now look into the diagram. Now when you look into the diagram, at t is equal to 0, what is the amplitude of the signal? It's 1. And everywhere else, right, everywhere else, what is the amplitude? It is equal to 0, correct? Now how will I define it? Del of t is equal to 0 for t not equal to 0, which means that other than t is equal to 0, what is the amplitude value? It is 0, right? Only at t is equal to 0, amplitude is 1. So what I can write one more statement like this. Del of t is equal to 1 at t is equal to 0, right? At t is equal to 0 and it is equal to 0 when t not equal to 0, correct? And you have one more statement here. Look at this statement, minus infinity to infinity del of t dt is equal to 1. The meaning of it is the amplitude of the pulse or the area of the pulse at t is equal to 0 is 1. That's the meaning of this statement, right? In all other places, the area of the signal is 0. Right, and it is called as a delta function. It is called as Dirac delta function or Kronecker delta function in the case of dt, and it is called as unit area signal. This is what I told you. At t is equal to 0, the amplitude, the area of the amplitude is 1. In all other places it's 0. That is why you have this equation. Del of t into dt is equal to 1 at this point, that is at t is equal to 0. Okay, right. In dt form, the same way, right? Del of n is equal to 1 for n is equal to 0 and del of n is equal to 0 for n not equal to 0. Right? Now since you just have a spike of the signal, where you can see is your thunderbolt. Right? When you hear a thunder, that signal is nothing but an impulse signal. And ECG function, when you see an ECG function, you just have a spike here. So that is also an example for impulse signal.